All right, up to this point in Chapter 12, we've talked about simplifying rational expressions as well as multiplying and dividing them. And so in section 12.4, we're going to talk about adding and subtracting rational expressions. And for those of you using the ebook, this is in the Intro to Algebra text in section 9.4. All right, so the first question here is asking us to add and subtract some numerical fractions. And so the key here is to find a common denominator. And so for 3/4 and 5/6, well, 4 and 6 both go into 12 evenly. And so since 4 goes into 12 3 times, if I multiply this 3 by 3, I'll get 9/12. And then since 6 goes into 12 twice, and 5 times 2 is 10, this fraction is 10/12. So combining those, I have 9/12 and 10/12. That gives me a total of 19/12. Okay. For 1/3 and 1/9, well, 9 is a number that both 3 and 9 go into evenly. And 3 goes into 9 3 times, and 3 times 1 is 3. And 1/9 is already set up for us, so it's just 1/9. And 3/9 and 1/9 is 4/9. All right. For subtraction, same concept, just first find a common denominator. And for 4 and 6, well, we can use 12. 4 goes into 12 3 times. 3 times 1 is 3. 6 goes into 12 twice. 2 times 1 is 2. And 3/12 minus 2/12 is 1/12. All right. And then lastly, 1/18 minus 5/12. Well, 36 is a number that both 18 and 12 go into evenly. And 18 goes into 36 twice, and so 2 times 1 is 2. And 12 goes into 36 3 times, and 3 times 5 is 15. And so now subtracting would give us minus 13/36. Okay. So it all comes down to finding a common denominator when adding or subtracting fractions. And so what I want to do now is look at how we can systematically find a common denominator, actually more than that, a least common denominator for expressions involving variable terms. So let's start with first factoring each denominator. So in order to build this LCD, we're going to need to do that based on the factors of each denominator. So if things aren't already factored out, we'll go ahead and do that. And then we're going to see if the denominators have common factors or not. And 2a says if the denominators have no common factors, then the LCD is simply the product of the denominators. Okay, so to illustrate this, let's say I have a half and a third. Well, 2 and 3 don't share factors, and so the LCD here would just simply be the product of those two numbers, so it would just be 6. For these two expressions, I have a denominator of y squared and a denominator of x cubed, and they don't share any factors, so the LCD would just be the product of x cubed and y squared. And then in this last expression, I have this entire quantity x minus 3 for my first denominator, and this entire quantity x plus 7 for my second denominator, and I don't have any common factors there, so again the LCD would just be the product of these two factors. Okay, so not too bad there. That's really the best case scenario. If your denominators don't share factors, just multiply them together to build that LCD. But now what happens if they do share factors? What do we have to do there? Well, 2b says if they do have common factors, then we're going to list each factor to the highest number of times it appears in any one denominator. The LCD will then be the product of those listed factors. So let's go ahead and illustrate this with an 18th and 5/12 to begin. So we already know that 36 is the least common denominator. right? And if you're working with numerical fractions, I mean, this process honestly is just overkill, right? Because you could just do some mental math and think, well, what's the smallest number that both of these denominators go into evenly? But nonetheless, I'll go ahead and illustrate the process because it's going to become especially useful in these last couple examples. So factor 18, and well, 18 is 2 times 9, but I can break down 9 as 3 squared, so this is 2 times 3 squared. Now, 12, on the other hand, is 4 times 3, and I can break down the 4 as 2 squared times 3. Okay, so then our LCD here can be formed as follows. So ignoring exponents for the moment, my factors are 2 and 3. So I'm going to need a 2 and a 3. And then I see that the 2 shows up as a square in the factorization of 12. So I'm going to need a square for the LCD on the 2. And then I see that the 3 shows up as a 3 squared in the factorization of 18, so I'm going to need a 3 squared for the exponent, or a 3 squared there for the LCD for this second part. And so now notice this is just 4 times 9 is 36, which we already knew, but again, this just illustrates the main idea. So now let's apply that to this next example. I have a times b squared for the first denominator and a cubed times b for the second denominator. So I'm going to need an a and a b, ignoring exponents for the moment. And then just note, hey, for the a, that shows up as a cube in this second denominator, so I'll need an a cubed for the LCD. And then the b shows up as a b squared in the first denominator, so we need a b squared. And that's it. For this third example, my factors are, again, ignoring exponents for the moment, x and x minus 3. And then for the exponents, well, the x shows up as a square here, so we'll need a square for the LCD. And then the x minus 3 shows up as a square, so we'll need a square there. Okay, and then for this last example, got 3 denominators. Same idea. Start off by just listing off all the distinct factors. So I'm going to need a 5, I'm going to need an x, and I'm going to need an x plus 5. So now for the exponents, well, the x shows up as an x squared here, so I'm going to need a square there. And then the x plus 5 shows up as a 4th power, so I need a 4th power there. Okay, so we'll stop there, and in the next video we'll look at some more examples illustrating how to build the least common denominator. All right, thanks.